Hello everyone, I'm Tharun. I'm going to present this poster called Solar, which is a new algorithm to train high dimensional sparse embeddings as opposed to low dimensional dense embeddings for the purpose of search engines. So sparse embeddings are very useful because we can replace costly near neighbor search operation with simple inverted index lookups, and sparse vectors require much less memory than the dense ones. However, inverted indexes are useful only when the number of items in each bucket is roughly the same. That is, we need load balanced lookups. Also, uh, training vectors with huge dimensions causes the wide output layer problem or the extreme classification problem. So in Solar, we make a couple of unique design choices. First, we initialize all the label vectors which are in such a way that they have exactly k non-zeros, and we ensure that the k non-zeros are spread out so that we can easily break these vectors into k different chunks. As shown in this figure, if we see, the vertical lines are breaking up the label vectors into k chunks. Um, each of these chunk will only have one non-zero, and we train k independent models with the chunked label vectors. So this ensures two things. First is we have load balanced inverted indexes. That is, every bucket will have roughly the same number of labels. And the second thing is that we also fix these label vectors throughout the training process and only train to map the query vectors. Now, during inference, when we get a new query, we parallelly predict with all the k trained models, obtain the scores, sort them up, and get the buckets with the best score. These buckets will give us the most relevant candidates. Among those candidates, the ones that have the highest sum of probability across all k models, that turns out to be the best and most relevant label. So in this way, we can avoid querying all the millions of labels. We can only look up few hundreds of candidate labels and obtain the best labels. So we experiment with 1.67 million book prediction data set and a bunch of extreme classification data sets with up to 3 million labels. We compare against industry scale algorithms like DSSM, which is on Amazon search, and Parable, which is on Bing search, and we get much better precision, state of the art precision, while inferring about up to 10x faster than the state of the art algorithms. So please read our paper that's going to be published at ICLR soon, and reach out to me for any more queries. Thank you.